In this example, we are testing the claim that the new balls have bounce heights with a mean different from 92.84 inches. Let's start with the null hypothesis and the alternative hypothesis. Again, we're testing the claim that the new balls have bounce heights with a mean that is different from 92.84. So we go to H1 and the mean is different from or not equal to 92.84 inches. And that's our claim. So that means the null hypothesis would be that the mean is equal to 92.84 inches. Now let's find the test statistic. We do not know the population standard deviation, so we need to find t. And t is equal to the sample mean, which they told us was 92.67, minus the mean that we're testing, 92.84, over the sample standard deviation is 1.79, divided by the square root of the sample size, which is 40. So work that out and round to 3 decimal places, and you should have negative 0.601. Now you can use your calculator to find t as well, and if you do, in this case you should end up with the same thing, negative 0.601. See the following viewlet to learn how to find the test statistic on your calculator. Now let's find any critical values. So from the not equal to and the alternative hypothesis, we know that we have a two-tailed test, and alpha is 0.05, so we have 0.025 in each tail, and 0.95 in the center. The sample size is 40, so the degrees of freedom is 39. And using table A-3, you should get the critical values of negative 2.021 and a positive 2.021. So the test statistic of negative 0.601 is between the critical values and not in either critical region. So that means that we failed to reject the null hypothesis. So the claim is with H1, and we failed to reject the null hypothesis. So that means there is not sufficient evidence to support the claim that the mean does not equal 92.84 inches. One more question. Does it appear that the new baseballs are different? No, there is not sufficient evidence to support the claim that the mean is different from the previous baseballs, so it does not appear that these baseballs are different.